Morning, everyone. I hope you're all pretty wide awake. Just to test that, who's heard of the cloud? Okay, good. I went to a talk. Colin, is Colin in the room? Colin this week was like, that's the baseline, right? If I ask a question later and I don't see that many hands, then I know some of you are probably asleep. So my name's Jon. I run the Scale Factory. We're a Devops and cloud infrastructure consultancy based here, primarily in London, but we're a remote-first team. We have colleagues around the country. And before that, I came through the startup mill on a mobile messaging app that was a bit like WhatsApp, but nowhere near as successful. And then before that, I was in the ISP industry, building infrastructure for web designers to deploy their websites on in sort of PHP 3 era. So I've been around this sort of area a while. I've got a beard, so you can trust me and my sysadmin credentials. You also can't see it, but I also have a lot of stickers on my laptop, which means you can trust that I'm a DevOps practitioner. The Scale Factory we're an Amazon consulting partner, and we've been going since 2009. We joined a program at Amazon called Well-Architected as an early access partner in April 2018. And since we joined that program, we've reviewed at this point around 180 distinct workloads on the Amazon cloud. We've embedded this review framework deeply into our consulting practice, and so we've got, I think, to me, this is a fairly kind of unique and valuable perspective, looking at the ways that a lot of people are doing things in the cloud, and being able to sort of make assertions about what you lot are probably doing in the cloud based on that data. And hopefully, the things that we've learned will be useful to you to take away and sort of look at in your own practices. One caveat I should say that the majority of the reviews that we've done have been for small and medium businesses with not a lot of like high-end enterprises. We don't really work very actively in that space. So if your environment is enterprise, this might not directly apply, but actually on the basis of the enterprises that I have spoken to, it's probably still true in those organizations as well. It's just that the data I have doesn't come from that world. So I'm going to talk a bit today about what well-architected is. I'm going to talk about what a well-architected review looks like, and then I'm going to talk about the things that we found through running that review process. The two things that I hope you'll get out of this is, one, hopefully you realize that you're not alone. We'll pick out some trends here and you'll be like, oh no, we do that as well. But the fact that other people are also making those same mistakes might make you feel a little better about yourself. But I'm also hoping that some of you kind of go away and go, actually, we're doing this pretty badly as well in our infrastructures, and we should probably look at that. So, what is well-architected? I should say that well-architected being an Amazon framework means that this is, I guess, most directly relevant to you if you're using AWS. Who's on AWS in the room? Okay, anybody on GCP? And Azure? Any other cloud infrastructure? Okay, a few Baidu Cloud or Ali Cloud people in the middle there, presumably. So the framework itself asks questions in a platform-agnostic way, but when we're reviewing infrastructures, it's mostly Amazon using customers, and we're mostly looking for Amazon-shaped answers. But a lot of this is probably still valuable to you, even though you're not Amazon users entirely. So the origins of well-architected are, this was originally a sort of collective internal knowledge within Amazon's solutions architecture organization. And as a solutions architect at Amazon, you would go out and talk to customers about how they built their infrastructure and ask them questions about what's working for them, what isn't. And so they, over a number of years, sort of built up this kind of, they call it tribal knowledge, but I'm not really keen on the terminology there, of like, what does good practice on AWS Cloud look like? And then they've taken that learning and codified it into a set of documentation and a review framework so that they can share that across the organization with a level of consistency. And in April 2018, they came to the realization that they wanted to review more Amazon workloads than they had solutions architects available for, and so they shared it with the partner network, which is how we came to get access to this. As I say, it's platform agnostic in as far as the questions it asks don't apply specifically to Amazon. You can run this with an on-premises workload. You can run these questions with a Azure or a GCP workload. You're more likely to do it if you're an Amazon user, but don't feel like you can't use this if you're not. Today, Well-Architected is now it's a set of white papers. These are quite Amazon specific. This goes through the design principles and recommendations of that framework on a sort of per area basis. We'll talk about what those areas are and talks about how to apply those principles using Amazon's tools. And there's also a review tool which exists in the console on the AWS platform, which is basically a multiple choice questionnaire. And this is the type of questionnaire where we've got this data from that we've used with customers over the last couple of years. So the well-architected framework covers these 5 pillars, as they're called. They go in order of operational excellence, security, reliability, performance efficiency, and cost optimization. And most organizations care about multiple of these. If you're a bank or a financial services company, or you're doing things with pharma, then you might care a little more about security than some of the other industries. Maybe cost optimization is more important to you if you're a startup. Those sorts of things. There's a white paper per pillar that you can go and read on the website. There's also what I refer to as lenses, and a well-architected lens is a collection of questions that relate to a specific type of workload. So if you're building serverless components or serverless applications, or you have an HPC or an IoT workload, there is right now white papers specific to those types of workloads and a number of additional questions in the review tool that apply to that. Right now, the serverless lens is the only one that's available in the online tool. The white papers contain the questions for the other two at the moment. So how do we use this, or how can you use Well-Architected as a framework? So it's a really good tool for gap analysis. There's a lot of the opinions in the review framework can be used to identify areas where you're not doing things particularly well, and you can use that to roadmap what you're going to do over the next 3 to 12 to 36 months to address those. It's a great teaching tool. When we run these with teams, invariably, even the person in the room who thinks they're the Amazon expert goes away having learned a bunch of new stuff, whether that's new product launches that they hadn't really heard about, or something that they weren't using quite correctly. And in larger organizations, it's really good on team alignment. As a governance practice, it's a really good way to sort of make sure that all of your teams are doing things in a consistently high quality manner. And so some of the enterprises that we have worked with, or the sort of bigger companies, use that to help keep their teams moving in the same direction, pretty much. You can probably use it using these ways too. So a review itself is where the data that I've got here has come from. It's 46 questions in the sort of standard review tool, and the other lenses add additional questions. It takes up to 4 hours if you're doing that in a sort of partner-led way. So it's sort of, we use it as a conversation starter a lot of the time as we go through the tool, ticking boxes. And it's very qualitative. Like when you're doing a review of this stuff, you don't need to gain access to the Amazon accounts. It's very much asking questions about, are you doing this practice? Are you doing that practice? Do you have this sort of consideration? And so it's quite high level. It's fairly technical in as far as it goes, but it's not a sort of direct analysis of the things that you've set up. It's a lot more about your operational practice and the way that you've made certain architectural decisions. The total number of questions is pretty big. If you were to be running an IoT workload, there's another sort of 11 security questions and 10 performance questions to look at. But those cover specific considerations for that workload. So I think the IoT stuff covers quite a lot of X509 certificate management stuff, because there's a lot of that in that world. Serverless covers a bunch of stuff around the things that make operating a serverless platform more difficult than a sort of regular containerized or EC2 workload. So I'm going to show you an example question and how each of those questions are scored, and then I'm going to take you through some of the data that we've got for some of the notable questions in that review as far as our findings are concerned, and then we'll talk a little bit about the implications of that. What does that actually mean? What can you do with that information? So the question I'm going to use as an example is the first question in the operations pillar. And the question as asked by the framework is, how do you determine what your priorities are? And what we're looking for here are that you're making decisions based on actual context. So you know what your customers need, whether they're internal or external customers. You're familiar with or aware of your compliance landscape. You're thinking about your threat landscape as well from a security perspective. You're making trade-offs based on those things, and using those trade-offs to drive your priority decisions. And you're looking at the sort of benefits and risks of each of those situations. This is kind of a sort of fuzzily laid out question. It's annoying that it's the first one on the framework because it sounds a bit weird, but really the question is, are you thinking about what you should be doing based on what your company needs? So the way that the scoring of the framework works is that each of the answers is given a rating, and that rating is either well architected, needs improvement, or critical issue. And so you get an overall score for this question based on the boxes that you tick in the tool. So if you ticked none of these because you're not making priority decisions based on any kind of context, then quite rightly that's flagged as a high risk, and that question will be considered high risk for that pillar. If you were to tick all of the well-architected boxes, then that would be flagged as a medium risk because there's still some other stuff to work on, and that would remain a medium risk until you tick every box in there, at which point you get a well-architected score. So reasonably straightforward. The way this is rendered in the console tool is quite nice. Each of the questions has links off to pieces of information and videos about how you could meet the goals of that question. And you do that 46 times, basically. So let's talk about some of the things that we found. So I'm going to start with the things that are good, like the places where most people are doing a pretty good job. That question that I use as an example is actually the question that more teams have got a well-architected mark on than any of the others. So most of the teams, 77% of the teams that we reviewed this data set is actually about 115 rather than 150 for reasons I won't bore you with. The majority of teams score well on this because they are taking into account their compliance landscape, their customer needs and so forth as they make their architectural decisions and their operational decisions. So it's likely that in your businesses you are also making reasonably good decisions driven by your business priorities. If you're not, you should probably just pack up and go home anyway. I don't know how you come to come to operate in that sort of vacuum way. The second highest number of well-architected ticks by question at 70% is around selection of storage. So there are a number of questions in the performance pillar about how you've made selections of specific types of infrastructure. So you'll be asked like how you selecting your storage, how have you selected your database, how have you selected your compute, how have you selected your networking options, and all of these really are around understanding what the characteristics of those services are in relation to the type of data you're processing or the type of app that you're building. So 70% of people have chosen their storage solutions based on an understanding of the characteristics of the thing that they're doing. And really what this means, I think, is we're using S3 because that's sort of the storage option that most people are doing anything with on the Amazon platform, is S3. But in some cases, that might also be recognizing that using EFS, for example, is a good way of achieving a sort of NFS shared storage-like layer within their application rather than doing some other thing. The questions around sort of architectural selection also usually mention, as in here, available configuration options. Most of the teams that score pretty well on their understanding of the requirements don't always score as well on their understanding of configuration options. Every component in the ecosystem typically has a number of things that you can tune and configure about it that you might not necessarily recognize. So, for example, if you're attaching block storage in the AWS landscape with EBS, you may not be aware that the number of IOPS, the IO operations per second, that are possible with that storage volume relates directly to its size in some circumstances. You may not be aware that there are other things that you can tune about EFS, for example, to perform one way or another depending on the type of files that you're storing on it, that sort of stuff. So most people are doing a good job of choosing their storage solution. Question 5 in the reliability pillar. 63% of the workloads that we've reviewed get a well-architected tick for this question. And this is about planning change, basically. 83% of people are making changes in a planned manner, which is fair. 67% of those people are deploying changes with automation. So not everybody has fully adopted automated change management at this point. And a worrying 6% of people are neither planning nor automating their changes, and presumably going through life just randomly deploying stuff on a whim into production, which hopefully none of you are doing. So those are the sort of top 3 things that teams are doing pretty well. Let's have a look at some of the things that are going badly. Question 9 in the reliability pillar. 79% of the workloads reviewed score a high risk in this area, and the smaller number under that, 87% of teams score either high risk or need improvement in this area, and that is planning for disaster recovery. So very few teams seemingly are making decisions about how they should be responding to disaster events based on, for example, business goals and so forth. So the first thing that you'd be expected to do if you're thinking about disaster recovery is to define what those objectives are. So your recovery time objective, your recovery point objective, how much data are we prepared to lose? How long are we prepared to be out for in order to meet the needs of our customers? And only a third of the teams that we reviewed the infrastructure for have actually thought it through in those terms. I think if you're looking at the sort of Google SRE type nomenclature, these are your SLOs, right? They're the things that you're trying to hit. Lots of teams are not really thinking about that in terms of disaster when things will go wrong. The same. Well, a third of people are also not defining what those recovery strategies are. So some of them aren't thinking about how much data they're willing to lose or how long they're willing to be out for. Some teams are not actually thinking about how they would get back on their feet in the event of an outage. And only a quarter of teams are actually testing any of these plans at all, which is kind of worrying. 16% of people are doing some automated recovery. That's usually the sort of use of things like auto-scaling groups to bring dead hosts back into life, or maybe people who are using Kubernetes where the pod controller is just going to reschedule those things. But this is the thing that most people are doing the worst is actually thinking about disaster recovery planning. Related, this is the second ranking highest risk issue for teams that we have reviewed. 75% of people are not doing a good job of responding to security incidents. And this, again, is about planning ahead for things that are going on in the security landscape. Only half of the teams surveyed actually know who they would go to and involve in the event of a security incident, which is kind of worrying. 27% of teams would know what tooling they would use to either mitigate or investigate a security incident. 40% of people have an incident response plan, which I don't think really matches the rest of the data. No teams at all have any kind of automated containment. So that's where you might quarantine a host or a container, keep it running, but stop its access to external resources, which is something that you can set up. Nobody really, like 11% of people have identified their forensic capabilities. So like they know how they would get onto those compromised instances and figure out what went on, whether that's through log analysis or using other security tools. Most teams, only 10% of teams are actually pre-deploying those sorts of investigative tools to their hosts, so that they would be available in the event of an outage. I think the model here is that if you're going to quarantine hosts that have been compromised, then you need to have on those hosts access for the people who would do the investigation and tooling for them to do that with before that quarantine happens. Otherwise, you risk unquarantining the host in order to get those tools on there, and then you're probably in more trouble. 3% of teams, which is probably two people that we interviewed, actually rehearse security incidents by running game days, and 35% of teams are not doing any of this. So there's very little thinking about how to go about dealing with a security incident were it to happen. And based on these stats, it's likely that 3/4 of you in the room today are in that same boat. When we're talking about security incidents, we're talking about exploited frameworks, so people getting to run untrusted code on your machines. We're talking about having failed to set up adequate access controls on storage services, so leaking data from an S3 bucket that's made public, that sort of thing, or as happened to one of our clients, they accidentally made some of their API keys public by checking them into a developer checked some dot files into a Git repo and immediately made those keys available to the world, which was not good for them, and they got away pretty lightly by only having run up some big Bitcoin mining bills rather than having all of their data deleted, which would have basically screwed them. So the third question that most people are doing badly at, again relates to security, and is again 75% of teams. Data classification, right? This is something that I think has got a bunch more attention recently with things like GDPR becoming noisier, and most teams don't really have a good idea of where their sensitive data lives. Ideally, you want to be able to say, this service has personally identifiable data in it, or this service over here has card data in it, or whatever, and make good access control decisions and good decisions about how you back that data up and how you ensure that it doesn't leak based on the sort of sensitivity of those classifications. I think some of this is because historically a lot of teams have used one big relational database for everything. I think if you're building microservices and you're allowing those microservices to have their own data stores, then you might be in a better position because you can kind of identify a particular service or a particular store that holds sensitive data. But many teams are not thinking about what data lives where, and that's likely to be a problem. Question in the cost pillar, 71% of teams are not scoring well on this, which is basically keeping up with the new products that Amazon are launching, basically. So a lot of teams are reviewing and implementing new services in an unplanned way, which is to say someone discovers one day that there is a service version of this thing you used to be running on EC2 instances and moves to it. I think this is quite an Amazon serving question. I think that they would like for you to be on a regular cadence looking at the new things they've released and deciding whether you can use them or not based on your workload. Most teams don't have a real sort of practice for this, which is fair because Amazon are releasing hundreds and hundreds of things every quarter. And it is difficult to keep up with, but most teams are not really keeping an eye on that landscape, and a lot of teams can save money or save sort of long-term engineering and operational time by adopting a service version of something that they were running themselves. So historically, if you were running Elasticsearch clusters, you'd be burning a lot of time and energy on that. You can now use an Elasticsearch service from the provider, for example. And then the fifth and final question I'm going to talk about in the sort of bad section, 67% of teams have high risk in questions around resilience testing. So that's you basically pre-thinking how things might fail and building plans for what you would do in that event, which relates, I think, very closely to some of the other things that we've already talked about. Most teams, 73% of teams they're conducting root cause analysis in the event that things do go down, which means that they are at least learning from the things that go wrong. But there's very little upfront planning for those incidents. Which is not great. If the first time you try this stuff is in an actual production outage, then you're going to do less well at it than if you've rehearsed some scenarios as well. So those are the good and the bad. I've also picked out a few questions that where I thought the results were not necessarily either good or bad, but they were notable for some other reason. Normally, that the sort of percentages down the sides are sort of skewed in an interesting way. So this was interesting to me. The question 3 in operations, this is about, are you using continuous integration, continuous delivery, basically? So how do you reduce defects, ease remediation, and improve flow into production? So it seems to be the case today in 2020 that most teams are using version control for stuff, right? The 10% that aren't, I worry about, but most of you are sensible people using Git or Subversion or Perforce or any of those kind of things to manage your source control. 87% of teams are claiming to test and validate their changes, so running sort of automated testing in their CI. There's nothing in this framework to ask about coverage, so it might well be that these are very basic smoke tests or kind of a smattering of unit tests, but most teams have some kind of testing involved in their delivery lifecycle, which is good. 78% of people are using config management systems. Great, that's good to see. Finally, most are using build and deploy systems, so presumably Jenkins, Circle CI, those sorts of tools. 37% only of teams are doing anything that looks like patch management, which is again a security thing, right? People are not updating software as new versions become available from vendors or from upstream, which is a bit of a problem. 57% of people are sharing design standards, which means that within teams, they have a mechanism to ensure that there's a level of consistency across what you're delivering. So you would score a tick in that box if you're, for example, using Terraform across a number of team members to deploy the same kind of cloud infrastructure within your environments. I think that the thing that really stands out to me here is making frequent small reversible changes, only 63% of people. So although we seem to have adopted like the CI/CD tooling, we're still delivering large batch changes rather than sort of incremental smaller changes that can be backed out of. It's good to see that in the data because anecdotally I kind of felt that was true. It's also notable that only 52% of people are fully automating the deployment of those changes. So again, we're not really living continuous delivery. There might be continuous integration going on, but there's half of the teams probably have a manual gate or some manual testing involved. it goes to show, I think, that continuous delivery practices, trunk-based development, those sorts of things are not really very evenly distributed across teams. I think we could all stand to do a bit better in that arena. Question 6 in the operations pillar. 46% of people got a well-architected tick for this question, which is, how do you understand the health of your workload? And this is a question about monitoring and telemetry. And in this review framework, we differentiate between application monitoring and telemetry, so I guess user behavior monitoring or real user monitoring, versus like workload behavior, so what resources am I consuming, those sorts of things. The thing that I find notable about this particular question is that a lot of teams are collecting data. Not very many teams are doing anything with it. So there's a lot of like, yeah, we know what our KPIs are. 55% of us know what our KPIs are. We've sort of defined what metrics we are interested in looking at, but only half of the teams have established baselines, so kind of an understanding of what normal looks like. A similar number of people are sort of learning what expected patterns of activity look like, and then the numbers sort of drop from there in terms of like people putting alerts on those monitoring items. And very few teams, 37% of teams, are doing anything around kind of going back to the KPIs they originally set out and sort of learning whether or not the metrics they're measuring meet those objectives. So we can stand to do better at monitoring, and this has been a theme forever. It's been interesting to me. We established the consultancy in 2009, which is when Devops as a word was first kind of being thrown around. And it's interesting to me that some of the things that we were talking about back then in terms of technology outcomes, so CI/CD, config management, that sort of stuff, monitoring, have made it to sort of fairly common usage. But things like monitoring are still pretty poor across the board. Security question number 2, 47% of teams have high risk on this one, which is about human access control. It's like, what do you allow your team members to get at in your environment? Most teams claim to be understanding what their requirements for access are. Only 58% of people are granting least privileges, which means that 58% of the people in this room are probably sat with a root equivalent account on your cloud platform that you don't need day to day for the most part. Thankfully, most teams are using unique identities on a per person basis, so we're not sharing root passwords around anymore, which is great. Only 70% of people are bearing in mind life cycle when they're managing credentials. So if you fire somebody from your organization, do you have a good mechanism for revoking their credentials? And you might want to achieve that through granting access through roles of federation, so using sort of single sign-on tooling and that sort of thing, but there's room for improvement there. And the automation of credential management is more or less non-existent, pretty much. And another security one that I found notable, 57% of workloads scored high risk on this, 89% scored high risk or needs improvements, and this is about programmatic access, which is what you're doing with API keys. So for the most part, if you're using a cloud platform, you will have access as a piece of running compute, you will have access to some kind of service that allows you to present tokens to other APIs and demonstrate that you are that service. So in the Amazon world, it's instance profiles. There's a local instance metadata service, so that if I do something with the Amazon SDK, if I don't specify any API credentials myself, it'll pick them up from the instance, and the instance can be given privileges, or that role can be given privileges over certain types of operation against the API. Very few teams are doing this sort of thing. And that's the sort of automate credential management part of this, and dynamic authentication is the other side of that. This is worth really looking at, and I think anecdotally we see a lot of teams who are still managing API keys and secrets, baking them into config for their applications rather than using secrets managers or HashiCorp Vault or those sorts of things. So this is an area that could be improved as well. I found that fairly notable. So I guess I've got about 10, 15 minutes to wrap up in, there are some major themes here. And I think that the thing that this data tells me is that for the most part, teams are okay at choosing the right services. Like you're choosing compute options that suit the type of compute that you're doing. So that might be traditional EC2 compute, or it might be that your use case is a bit more bursty or done on a kind of on a much more sort of SaaS basis, in which case Lambda and serverless compute is a good thing to be looking at. Most of you are choosing good database options. So if your data is very sort of if your data is relational, you're choosing relational data stores. If it's very sort of document-based, you might be looking at DynamoDB. You're generally, as a rule, teams are making good choices about which parts that they use. So they're good at the architecture piece, I guess, the design piece. The place where teams get compute choices a little bit wrong is usually around sizing. So there are there's a plethora of different instance types, instance classes, and instance sizes, and often we see that compute is over-provisioned, or maybe you've selected sort of in the Amazon world a T3 instance class, which is geared up towards bursty workloads, but actually you're doing quite a lot of consistent computation. So there are times when that instance is throttled as far as compute. So maybe M5s are a better option in that case. So in general, that's the area that could use some improvement. Is that, have I chosen the right class of compute node? Have I matched that to my requirements? So in general, teams are good at choosing the components that they're building with. Great. Most teams, seemingly, from this data, are okay at making software changes, right? You're using automation tools, even though you're not necessarily automating everything. So full continuous delivery seems to be a little out of reach for some people. Often, like anecdotally, it's been my experience that that's sort of fear or risk thing. Teams are unwilling to kind of do full CD because there's still a lot of manual testing required in their pipeline, or they're still releasing large batch size changes, and so it's risky to allow those things to flow straight into production. And so change batch sizes are, as a rule, I think, too big for most teams. And I think those two are related. If you can make your batch sizes of change smaller, then you'll probably be able to adopt full CD more readily. If we look at this is from the Accelerate State of DevOps report 2019. If you haven't read Accelerate as a book, Gene Kim, Jez Humble, Nicole Forsgren, actually that's backwards order. Nicole's done all the work on that one. The high-performing teams are typically typified by the fact that they can deploy on demand, basically, like multiple times a day, and can do so with a short lead time, that they can restore service quickly in the event of an outage. So that sort of mean time to recovery stat is important, and make fewer changes that cause failure. And a lot of the stuff that I think I've seen in these stats kind of points at the teams, like most teams probably being sort of medium-low performers that we've seen in this landscape. You can download this doc from Google. There's a lot of other good stuff in there, but I like to go to these stats as good sort of organizational health metrics as far as DevOps practice is concerned. Teams generally, I think, are bad at thinking about failure modes. I think that's what this data tells me. There's a lack of consideration of business requirements. So, how long can you be down for? What if you agree with your customers? What's in your contracts? Do you know that? We've certainly had conversations with a number of CTOs who have either not contracted anything specifically with their clients, or have basically made ludicrous promises based on their architectural designs about availability that doesn't really match. And so sort of walking teams through a better understanding of what they're committing to is a good thing to be doing. There is almost no risk analysis of failure modes, really. We're not thinking about how could this go wrong. And I have some hypotheses about why that might be. I think when we were building this stuff on premises, there was more stuff to get wrong. We were responsible for more things. And so we were maybe a little bit more thoughtful about failure modes, clustering, failover, those sorts of things. I think there's a bit of an assumption that by putting this in the cloud, you've made this somebody else's problem. And whilst that's true for some aspects of your infrastructure, that's not true across the board. So thinking about failure modes is something that you need to be doing within the context of your app and your business requirements. For the most part, teams aren't documenting anything, and they're certainly not writing good documentation to follow in the event of an incident of some sort. If you're not doing sort of incident planning ahead of time, then you are cognitively impaired during an incident and you don't have anything to crib from, so you're making it up as you go. If you can rehearse this stuff in advance, you are more likely to succeed and make good decisions during an incident. And thinking through failure modes, how you would identify them and how you would resolve them is something that pays off and doesn't take an awful lot of time, really. You've just got to kind of make the opportunity to do it. And there's very little attempt to rehearse those sorts of outages as well. This is an example of something that we do with teams from time to time. So we worked with a team last year who they built an application. They were about to advertise it on television, so they were expecting a large amount of traffic, but their platform, they were not convinced was going to be able to withstand it. And so we did some performance tuning work, but we also did this, which was basically a risk register of the platform. And what we've done here is enumerate all of the components in the environment, and for each of those components, think about the things that could go wrong with it. So in this case, there was a lot of Lambda in here, and so we've got things like a manual deployment error, right? Somebody deploying the wrong stuff is a risk. Cold start delay, which is a concern for Lambdas within VPC environments in the event of a scale out. Lambda concurrency limit reached, so we're now executing too much compute. We can't handle any more requests. So for each of those risks, we've identified how likely they are, what the impact is likely to be, and that's just a sort of low, medium, high activity. We've thought about how we would identify it, so what we could monitor in order to know that thing had happened. And we've also highlighted a mitigation, so if we can solve that problem ahead of time, either by building some automated remediation or sort of taking that problem away entirely by reconfiguring something or something of that nature, what we can do there. And then a runbook action, so kind of what we would do in the event of that thing in order to get things back up and running. That column is the least fleshed out. That informed a larger set of documentation for how we'd follow those instructions. And then the final column is a list of Trello cards that relate to work that we would do to mitigate those risks. So that actual risk planning exercise was probably just 2 days' work. And that was, a couple of our people and some of the application developers answering questions like, if the database goes away, what happens to your application? Does it reconnect? Does it reconnect properly? Is it re-resolving the DNS name? Like those sorts of things. And in some cases, we come up with questions that needed answering, and those would go on the backlog as well. So answer the question, if the database goes away, how does the application behave? If the answer is I don't know, then going away and doing some work to get to that understanding is a good thing to do. As well as being bad at doing anything about failure modes and thinking about failure modes, we're bad at monitoring for them. We're collecting data in some cases, but not really doing things with it. And I think that's missing an opportunity, really. And I think this is related to the question about whether you're thinking about failure. Unless you're thinking about failure modes, you don't know what to monitor for. Most of the monitoring that's going on is probably just sort of high-level resource consumption metrics that never really get looked at until something starts going wrong. And interestingly, almost no tracing is going on. So this is sort of like request tracing through a stack. So in the AWS world, that's X-ray. Maybe it's also Honeycomb if you're a Honeycomb user. There's not a lot of that going on. Even in teams where you're building microservices or building distributed sort of Lambda-based platforms, there's not a lot of that happening. And that's just flying blind. Like you don't know what the hell is going on in your platform if you are not tracing. And the more you decompose your architecture into smaller pieces, the more that's important. Teams need to do better at security in general. I think there's still poor hygiene around patching, which is pretty inexcusable, I think, in 2020. There's not a lot of data classification, which is something that I think we need to get better at as an industry. Human access control isn't great. Like most people have more privileges than they need. Most software components that need to access services are also not being very well access controlled. And there's not a lot of adoption of security monitoring tools, which goes back again, I think, to thinking about failure modes as a way of driving and understanding of what you need to monitor. One such failure mode might be, there's been a massive security breach. Like, how do you know that that's happened? From the OWASP top 10 breaches, I think this is 2017 data. I cribbed this from a Sneak blog post. But the top causes of security breaches in 2017 versus the OWASP list were using components with known vulnerabilities. That's not patching your application. It's not patching your infrastructure. And people are doing badly at that. Please start patching things. Security misconfiguration, so accidentally making your S3 bucket full of private data available to the world, or like bad security group rules, that sort of thing. Injection is the third. You can mitigate that with a web application firewall to some extent. Weak auth and session management and missing function access control. All of that stuff is potentially dangerous to your application. But really, most teams are not eating their vegetables. They're not patching their stuff. One good way of looking at this from an architecture perspective is, actually, if I'm currently running my workload on regular compute instances, so EC2 instances, maybe if I were to migrate to Fargate or a containerization platform, I remove the need to do a lot of patching because I no longer have responsibility for the operating system that my stuff runs on. All I have to worry about then is the app. So you're reducing your kind of give a shit surface to things that actually concern your application and your business case. So I think the primary takeaway here is that everyone is better at building platforms than they are at securing or running them. And this is, I think this is the real lesson, and it's a very high chance that this applies to you and your teams. Where you can go from here, other than sort of, I guess, paying attention to the things I've just been saying for the last 45 minutes, is to go, if you're an Amazon user, go and read the white papers for Well-Architected. The white papers are a really good sort of dense way of consuming information about AWS. There are a number of product white papers that are pretty interesting as well. Like if you're studying for any of the AWS exams, like the white papers are the things you really want to be spending your time on. Run your own reviews. So that Well-Architected review tool exists in your console today. It's not in all the regions, but it's probably in the regions that you're in. So you can go and start working through those questions, following the links to more information, understanding how you've got to, what your own practice is like. And consider engaging a partner for this as well. The third-party perspective is probably one of the things that's been the most beneficial to the people that we've run these reviews with. There are also funding programs available if you're an Amazon customer and you use an Amazon partner to do your well-architected review. There is $5,000 of credit funding available to help fix some of the things that are found. So there's benefit financially, I guess, as well as kind of knowledge-wise to engaging an external party to do these things. We're an Amazon partner. We can do these things. There are other partners as well. If you are currently working with an AWS partner, ask that partner if they're a well-architected review capable, if they haven't offered you that already. That is pretty much it. I think we have maybe 50 seconds for questions. There's mics down the front if you'd like to hear them.
Are there any questions? We've got time for like one. Somebody over there.
Thank you. Hi there. Thanks for the talk. My company's moving a large project into the cloud at the moment. One of the mandates is to be cloud agnostic. We're in GCP and Amazon. So one of the things that have come down from the higher ups is that we should try, wherever possible, to not use a cloud-specific service. How does can you speak to that at all? If you want to be able to kind of jump between GCP and Amazon, if you want to effectively use them as two different regions, what can you say about that?
Cool. So what I can say about cloud agnosticism is that it's kind of bullshit. That's my sort of opening comment on it. Basically, you can't do anything in any cloud without coming up against something that is cloud specific, right? Anything that you do in AWS, the security model is controlled by IAM, and IAM is an Amazon-specific service. So as soon as you do anything there, you've touched something Amazon-specific. I think when I'm having these broader conversations, I think that the question needs to be why? Like, why is cloud agnosticism that important, right? Is it economic? Is it you want to use one vendor to beat the other up, that sort of thing? I think you can look at, I'm an Amazon partner, right? So I know most about that ecosystem. Amazon's prices drop every year. No prices are going up. No one's locking you into that ecosystem. And so if it's an economic argument, I don't personally think that holds any weight. If you're building something that you want to be cloud agnostic, right? The absolute base, the sort of lowest common denominator you can get to is there's some compute, there's some storage, maybe there's a managed database service, blah blah Kubernetes probably, and as soon as you sort of start consuming those anything beyond those services, you kind of look at it and go, okay, so we want to use Elasticsearch, so we're going to build in both clouds our own Elasticsearch on our compute services. Well, now we're running our own Elasticsearch platform, and we've got to patch it. You're not going to. We've already proven that. You're going to spend a lot of time and manpower on like running all those additional things in order to protect yourself from this weird, unlikely future world where you have to negotiate price between two cloud vendors. Like, I don't think it makes sense. I wouldn't go at a cloud agnostic strategy for that reason. I think the places where you can do that, if you're in media delivery, for example, let's say you're a television company. I've done a bunch of work with one such company, and you are delivering video, right? You can deliver your video assets into multiple CDNs, multiple cloud platforms, and deliver from there and spread the load dynamically, sort of consistently over time. And content pricing and content delivery pricing is something that is more negotiable generally across vendors than other things. But the idea that you'd want to make everything entirely cloud agnostic sounds to me like a big waste of engineering hours that could be spent on application and stuff that your users care about. And it isn't that. I promise you that. Cool. All good. Thanks very much.